In this exercise, I will go through the text generation problem using recursive neural network. This is done as a part of in-class programming assignment number 6. So we first start our exercise by importing the necessary libraries. So in our case, we have used TensorFlow, NumPy, OS, and time. So once we do that, let's go to the data, downloading the data. I want to mention that following the requirements specified in the assignment document, I have used a different data than whatever was used in the classroom. I have used a novel by Sir Arthur Conan Doyle as the data source, which is Sherlock Holmes, Adventure of Sherlock Holmes, and I got it from Project Gutenberg. Uh, Basically, I got the text file of the novel and then I stripped the standard header and footer specific to the Gutenberg project, and then I stored the file at my GitHub repository uh, in the submission folder so that anyone can run the code to verify the results. One word of caution though, when executing the code, one has to generate the token. Basically, this is automated in GitHub repository, but you have to basically you have to go to the, you have to go to the URL and then view the raw files in the GitHub, and that way you will generate the token, and you can use that URL here to get the file inside our environment. So we established the path to the file and also the read the data and decode it using this part. So let's verify the code. The length of the text is 561,833 characters long, and then I have printed first 500 characters, which looks consistent with the data. So the next part is the vocab part. The vocab created here in this particular segment of code uh, is you basically basically achieved by applying a sorted set to the text. Set means we are making unique characters, and sorted means we are sorting those characters. So it's given here, and then we created the required mapping. So we first do mapping of the characters to numbers and then mapping numbers to characters. I have printed those as for reference. The next step in our exercise is to create the training examples and targets. We want to create the training sample to perform the prediction task in the model. So I have divided the text into sequences that each sequence so that each sequence that I can use as inputs to the training contains 100 characters length. So one such input is shown here, adventure, for example. So there are sequences that I have created using the batch uh, function. You can see there are, I've printed 5 sequences here and joined them together. You can see a clear sequence. Now the method split input target here. This one is used for shuffling the data and pack the data into batches. So um, then I've used a batch size of 128, a larger batch size compared to whatever we did in the class. Why I did the larger batch size? In order to smoothen the gradient of the text. Um, I mean, this is a hyperparameter to the model and we can play with it, but I chose it to smoothen the, the gradient, the text gradient. It comes with a larger computing cost, but I am using GPU to parallelize most of the computing tasks. So finally, this is the data set. I've defined it in this way, and you can see the batch data set, the shape of the batch data set shape here. So next part is to build the model. There are four layers model I built. Um, First layer is embedding the input layer. Next layer is the uh, recursive neural network, which is the core part of the neural network. I have used LSTM recursive neural network framework. I could have used GRU as the classroom as well, but I've used LSTM because LSTM is found to be faster than GRU, and also the loss is less for LSTM. Um, these both characteristics of the LSTM compared to GRU are taken from a peer-reviewed article which I put specified in the PDF file. Then we have used a dropout layer which I've introduced following my previous exercises, previous ICP exercises, just to eliminate the noise. Finally, the dense layer is the output layer. So this here I build the model and then I try the model, printed the summary of the model. Finally, let's see how the model works. So basically, in order to do that, I have uh, I've done some I've done some actual predictions from the model, and it is done by sampling from the output distribution, and then the distribution is defined by the logits over the characters. So then I compile the model with Adam optimizer. The loss function is defined here. Finally, I established the checkpoint just to make sure that our model is saved at each epoch the loss decreases, and this is done by model checkpoint function. Finally, I executed the training for 50 epochs compared to just 10 in the sample file we got for the assignment. You can see that as we increase the number of epochs, our loss is decreasing. So that's why I've used 50 epochs. Well, yes, I could have used more epochs to do the further experiment. In fact, that is something we should do during our project. Then I generated the text. You can see the generate text is taken care of inside this method, which has three input parameters: model, the model we define, the start string, and the number of characters we want to generate. So here is the output. So we just generated a text a sequence of text, basically sequence of character, specified the beginning starting text, and then we can see that it created a text following Arthur Conan Doyle's style, the style followed in the novel, in the document, the data. So you can see that this is a good example of text generation, because first of all, the paragraph, the sentence beginnings are marked by capitalized letters. There are quotation marks for the dialogues and also demarcation for the paragraphs. So in this exercise, I've learned to generate text using recursive neural network. Thank you so much.